Ever wondered how the world of thermodynamics engineering shapes the realm of design and manufacturing? How does it blend theoretical knowledge with practical skills to create innovative solutions? This fascinating field has a lot to offer to those who choose to explore it. Delving into the curriculum of thermodynamics engineering, we find a broad array of topics, each playing a pivotal role in shaping versatile professionals. One of the cornerstones is the understanding of engineering design principles. These principles guide engineers in conceptualizing, planning, and creating solutions that optimize energy usage and efficiency. Next, we have computer-aided design, or CAD, an indispensable tool in the modern engineer's arsenal. Through hands-on experience with CAD software, engineers can digitally model and simulate complex systems, refining their designs before they even leave the drawing board. The curriculum doesn't stop at design, though. It follows the product development lifecycle from ideation to prototyping, testing, and refining. All of this with a keen focus on energy-efficient and sustainable design. Then comes the understanding of manufacturing techniques. From casting to machining, forming, and even additive manufacturing, students delve into the methods that turn ideas into reality. Materials science forms another crucial part of the curriculum. Understanding the properties and behaviors of materials allows engineers to make informed decisions, choosing the right material for the right application. Quality assurance is also emphasized, teaching students how to implement rigorous testing protocols and adhere to industry best practices. This ensures the reliable and high-performance solutions that the world demands. Interdisciplinary collaboration is encouraged too. By working with professionals from fields such as mechanical engineering, materials science, and industrial design, thermodynamics engineering students become well-rounded, capable of tackling complex challenges. Innovation and creativity are not left behind. Engineers are encouraged to think outside conventional boundaries, fostering the development of cutting-edge solutions. Finally, environmental considerations are integral to the curriculum. Students learn to assess the environmental impact of materials, processes, and end products, integrating sustainable practices into their work. In summary, the thermodynamics engineering curriculum is a comprehensive journey that arms students with a versatile skill set. From understanding engineering design principles and mastering CAD to exploring manufacturing techniques and materials science, it covers all bases. It emphasizes quality assurance, encourages interdisciplinary collaboration, nurtures innovation, and fosters environmental consciousness. So, as graduates of thermodynamics engineering venture into industries ranging from renewable energy to aerospace, they bring with them a wealth of knowledge and skills. They are poised to contribute meaningfully to global technological advancements, shaping the world as we know it.